We're going to be examining the population growth equation. You could call it the population growth formula, the population growth sequence. It's all the same thing. This equation is used to calculate the increase in size or the reduction in size of some value that changes at the same rate for the same interval of time. And populations is just one area where this can be used. It can be used for the growth of plants, for the growth of bacteria, and pretty much anything that changes at a constant rate. Let's begin by looking at a problem that we might typically come across, which would require the use of this formula to solve. And we're going to do two things. We're going to deconstruct the equation in order to understand how it works. And then we're going to explain the part in the brackets that tends to cause confusion in some students. So here's the question. The population of an island is 7,900. The island population is predicted to grow by 3% each year for the next several years. What will the island's population be in 7 years? I've highlighted the important values in yellow: the initial population, the expected percentage growth, and how many years population growth we want to calculate. And the equation is what we can use to calculate the growth, and that will give us the predicted size of the population in 7 years. Anywhere that says n in the equation, we plug in the number of years. A sub 0 is the initial population, and R, which stands for ratio, is the amount of growth that occurs within each period. So that's 3%. A sub n is the result you get from plugging in all the values, and that will be the size of the population after 7 years. But before we answer this question, I want you to understand exactly why the formula even looks like this, and where each part of the formula comes from. We'll also answer why we're adding 1 to the amount of growth that occurs within the brackets. Let's focus on the amount of growth that occurs within each period. That's 3%, which is the value that's given to R. Now, if we plug that value into the brackets, we get 1 plus 3%. What is that equal to? Well, can you see the problem? In the brackets, we have a number and an expression, and we're trying to add them together. We're trying to combine them, but that can't be done. They would have to be of the same type in order to be combined into one element, which is what we're trying to do with addition. Because the final result we need is a numeric result, this sum needs to be a number, so we need to convert the percentage expression into a number. Well, R is 3%, and 3% is just 3 out of 100, but that can be rewritten as a fraction, which is 3 divided by 100, and that equals 0.03. So the expression on the right hand side of the bracket can be rewritten as 0.03. Now 3% is the amount by which the population is growing, so it's an increase. But here's something interesting. We've just shown that 0.03, which is equal to 3 over 100, represents 3%. So let's say we wanted to find out what 3% of 100 is. We would multiply 100 by 3 over 100. Of course, because this is an equation, you need to do the same on the other side. Multiply that by 100. On the left hand side, the 100s cancel, and that shows that 3% of 100 is 3, which we know to be true. But on the right hand side, we have another way of expressing that, and that is 100 times 0.03. So to get 3% of a number, we simply need to multiply it by 0.03. Now let's say we had a number such as 100 and we wanted to increase it by 3%. That's going to give 103, right? 100 with 3% on top. But we could write it as 100 plus 3. But we could rewrite the 3 using this equation. And so that would be 100 times 0.03, and that would be added to 100. 100 plus 3 is exactly the same as saying 100 plus 100 times 0.03. Since both of these numbers are multiples of 100, we could factor out the 100. So you'd get 100 brackets times 1 plus 0.03. And that's the same as 100 plus 3, which is 103. So if you wanted to increase the number 100 by 3%, you simply have to multiply it by 1 plus 0.03. It doesn't matter which number you increase by 3%, it works for all numbers. So if I wanted to increase a sub 0, I would multiply it by 1 plus 0.03. And that works because if you distribute the brackets, you're getting a sub 0 times 1 plus a sub 0 times 0.03, which is 3% of a sub 0 on top of a sub 0. But we saw earlier that 0.03 equals r, so this really is a sub 0 plus a sub 0 times r. And since both parts of this sum contains a sub 0, we can factor out a sub 0, and that gives us a sub 0 times 1 plus r, which is the main part of the right hand side of the equation for the growth that we're trying to calculate. The last thing we need to do is show why this is taken to the power of n. Well, it's actually not too difficult to show why we use the brackets to the power of n. The first year is a sub 0, which is the initial population. 1 year later, when n equals 1, the population increases by 3%, which means we multiply a sub 0 by 1 plus 0.03. The next year, when n equals 2, the population is the previous year increased by 3%. The previous year is a sub 0 times 1 plus 0.03, and to increase that by 3%, we multiply that by 1 plus 0.03. So it's a bracket squared, and obviously the next year, when n equals 3, the size of the previous population increases by 3%, and that means we multiply all of this by 1 plus 0.03. So in effect, that is a sub 0 multiplied by 1 plus 0.03 squared, multiplied again by 1 plus 0.03. And that's just a sub 0 multiplied by the brackets cubed. So hopefully you see that every time we increase the population by 3%, we're multiplying by the brackets once, which increases the power by 1. And so that must mean that after 7 years of growth, when n equals 7, the population, which will be a sub 7, must be equal to a sub 0, which is the initial population, multiplied by 1 plus 0.03 to the power of 7. And now you'd be in a position to answer what will the island's population be after 7 years. If you plug all the values into the calculator, you get that after 7 years, the population of the island will be 9,716. In case it escaped your notice, what this really is just a geometric sequence where we multiply the initial value by some other value to the power of n. And starting at the initial value, each year's population change can be written as terms in the sequence. Well, that's it for now. I hope this was helpful. Thanks for watching. Until the next video.